You know, this story of artificial intelligence is wild. It's this tale of massive sci-fi dreams, really harsh reality checks, and then this recent absolute explosion of progress that is changing everything. It's been a cycle of incredible hype, followed by crushing disappointment, over and over again. So how did we get here? How did we go from these abstract ideas to AI that can write code, create art, and even start to reason? Well, let's break it down. It all comes back to this one simple question. Seriously, almost everything in modern AI can be traced back to this. In 1950, the brilliant mathematician Alan Turing puts out this paper, and he just asks, can machines think? And this wasn't just some philosophical game. He actually proposed a test, what we now call the Turing test, to see if a machine could fool a human into thinking it was also human. That single question basically lit the fuse for the entire field. And that fuse led right here to the very first era. The dream of actually building a thinking machine really took off in 1956 at a summer workshop at Dartmouth College. This is where a small group of researchers got together and officially made AI a real academic field. They even coined the term we all use today, artificial intelligence. You can just imagine the energy, the feeling that anything was possible. And you've got to meet the pioneers, right? The founding fathers of this whole thing. Of course, you have Alan Turing, who set the entire stage, John McCarthy, who literally gave the field its name, Marvin Minsky, who was just constantly pushing the boundaries of what a machine could do. Then there's Frank Rosenblatt, who created the perceptron, a really early but super important ancestor to the neural networks we have today. And Alan Knoll and Herbert Simon, who actually showed up at that Dartmouth conference with the very first AI program. I mean, these were the giants. The entire field was built on their shoulders. And the optimism back then, oh, it was just off the charts. They truly believed they were just a few years away from cracking the code of human intelligence. This quote from Marvin Minsky in '67, it just says it all. And he wasn't some outlier. This was what most of them thought. They had these early programs that could solve algebra problems, prove theorems. It really felt like the finish line was just around the corner. Yeah, so about that finish line, turns out it was a total mirage. That first big burst of progress just slammed headfirst into a wall of insane complexity. This kicked off periods that we now call the AI winters. This was the bust that followed the boom, a time when all the funding dried up and that initial excitement turned into some serious skepticism. And look, the gap between what they promised and what they could actually do, it was just massive. They were promising thinking machines in like 3 to 8 years. But what they had were these simple programs that could only solve what they called toy problems, really specific tasks in a totally controlled setting. So when the big promises didn't come true, the people with the money, like the US government, they just pulled the plug. And the whole field pretty much went into a deep freeze. So why did it all fall apart? Well, it really came down to three huge problems. First, the computers themselves. The processing power they had was just a tiny, tiny fraction of what's in your phone today. Second, this problem called the combinatorial explosion. It just means that for any real-world problem, the number of possible choices and outcomes gets astronomically huge, way too big for those early computers to handle. And third, maybe the biggest one of all, was the common sense knowledge problem. They just totally underestimated how much stuff we humans know without even realizing we know it. I mean, how do you program a computer to understand that rain makes things wet, or that you can't be in two places at once? These were the walls they hit that stalled progress for decades. Okay, so after those AI winters, it was pretty obvious the old way just wasn't working. To break out of that cycle, they needed a completely new approach, a fundamental shift in how to even think about building an intelligent machine. The old way is what we now call symbolic AI. The idea was basically to get a bunch of experts in a room and have them painstakingly write down every single rule for how to think about a problem. If this happens, then do that. It was all hand-coded, but it was brittle, it took forever, and it just could not scale up to the messiness of the real world. But then came the new way, machine learning. And this was a total game changer. Instead of trying to hand code all the rules, the idea was to build systems that could figure out the rules for themselves, just by looking at massive amounts of data. All of a sudden, AI wasn't being programmed anymore. It was being trained. This was the turning point. And if machine learning was the game changer, deep learning was like putting it on rocket fuel. It's a type of machine learning that uses these really complex, multi-layered neural networks, kind of inspired by the structure of the human brain, and it was powered by a perfect storm of three things. 1, massive amounts of data from the internet. 2, incredibly powerful GPUs, the graphics cards that were originally built for video games. And 3, just smarter algorithms.
This is what finally unlocked all the modern magic, like computer vision, speech recognition, and understanding language.
All right, so this whole data-driven revolution brings us right up to the last decade, the moment AI finally stepped out of the research lab and into all of our hands. This is where we enter the age of generative AI, where these systems don't just analyze information, they can actually create brand new things. The one technical breakthrough that unlocked pretty much everything we're seeing today dropped in 2017. It's called the transformer architecture. The secret sauce was something called an attention mechanism, which let the model understand context in a much deeper way. It could figure out which words in a sentence were the most important. It was more powerful, way more efficient, and, crucially, you could scale it up to be enormous. Pretty much every major AI model you hear about today, it's built on this foundation. And once the transformer was out there, man, the pace of progress just went vertical. It's been absolutely breathtaking. GPT-1 came out in 2018. Just 2 years later, GPT-3 was this quantum leap forward. Then, in 2022, ChatGPT just explodes into the public consciousness. And now we're already talking about a reasoning era, training models to actually think through problems step by step. The speed is just hard to wrap your head around. And if you want to understand just how huge that public explosion was, ChatGPT hit 100 million users in 2 months. 2 months. At the time, that made it the fastest growing app in history. This wasn't some niche tech thing anymore. It was a global phenomenon.
Okay, so after that whirlwind tour through history, the obvious question is, where does this all go from here? And to understand that, we kind of need to look at the theoretical roadmap that researchers are aiming for.
So, researchers usually think about the future of AI in 3 big stages. First is narrow AI. That's where we are today. Everything we have, no matter how impressive, is still a narrow AI. It's really good at one specific task. The next hypothetical step is artificial general intelligence, or AGI. That's a machine that could learn and do pretty much any intellectual task a human can. And then beyond that is the idea of a super AI, an intellect that is just vastly beyond human capabilities. Now, let's be super clear, we are 100% in stage 1 right now. AGI and super AI are still, for now, science fiction. And that brings us to the final and maybe the most important question. The entire history of AI has been this roller coaster, these huge booms of optimism followed by these crushing winters of disappointment. So looking at the absolutely unbelievable progress we're seeing right now, you have to ask yourself, has that cycle finally been broken? Is this time really different? That's the billion-dollar question that everybody is trying to answer right now.